Got it.
Thank you, John.
Okay, on.
Okay, thanks again. Welcome back. Claude here. Going to talk about the National Building Code today. Basically, what I'm going to be presenting is about 1 hour of, we'll say, typically what would be involved in about a 40-hour course. Really, to study building code into any great depth certainly takes a lot of time. As you likely know by now, if you look at the building code in its physical presence, it's 2 large volumes of lots of what I like to tell my students in the past, good bedtime reading. Probably guaranteed to put you to sleep. Anyways, the building code, as you likely have found out, is divided into a number of parts dealing with the size and the use of buildings. And when we talk about the various parts, it really subdivides it down into what I call the specialty fields, whether it's something to do with site preparation, site planning, foundations, framing, plumbing, a little bit of heating and electrical. On the heating and electrical side, just as kind of a side note, there are other codes that prevail. Certainly the National Building Code gives us some general overviews of expectations as far as codes are concerned. We can see here on this initial slide, opening slide, it's based on the NBC, National Building Code 2020 version. But every 5 years, there's a new version comes out with updates. So just to kind of give you a general idea, the previous code, 2015, it had well over 200 changes, modifications. So again, it's an evolving process of what is the latest and maybe perhaps the greatest in construction requirements that people should be adhering to as far as construction of buildings of any sort. So let me move on a little bit here, if I might. Okay, so the building code process, and typically when we take a look at it, we can look at it from various different points of view. So a lot of it can be simply reviewing the code. It's certainly used a lot by architects and engineers as a design tool. Certainly it's a standard. And certainly when we look at the construction or the build stage. So all 3 elements, if we take a look at it, are involved. So it basically has to involve a lot of different people from a lot of different aspects, whether it's the person that's going to be finishing the drywall or simply pouring the concrete for the footings. So again, we're going to talk about it from sort of, we'll call it the user's guide point of view. So when we look at the overview, again, sort of an image of the National Building Code Volume 1 off to the right-hand side. What's it all about? So construction is largely governed by many different legislative acts, codes, and standards, regulations, and bylaws. So for example, if I wanted to build a new house, I have to go through a number of different, we'll call it steps in the process. Well, first off, I'd have to go through zoning. I'd have to get an architect or someone to design that house, get it approved, get a permit, and so on and so on. But what's really, really important here is understanding all the regulations that are kind of intertwined when we talk about construction. John, did you want to talk a little bit maybe on that second point about authority having jurisdiction?
No, thanks, Claude. So one of the challenges in many First Nations communities is the authority having jurisdiction. And basically, what this means is off reserve, for example, if I'm going to build a home in Ottawa or Montreal or any other city or town, I must apply for a permit to the city because they are the authority having jurisdiction. They are responsible to make sure that my home is built to, one second, is to make sure that my home is built to the building code, because they are legally responsible to make sure that it is built to code, that it is safe. And that's why you have inspections, etc. In First Nations, the authority having jurisdiction will really require bylaws that specifically state that, the National Building Code 2020 will be enforced in our building, in our community. And what we found is very few communities actually have any type of bylaws. So for example, an inspector cannot issue a stop work order because they don't have the powers under the council to issue a stop work order. So very few communities, if they see a home that being built properly, they don't have the authority to issue stop work orders. So we're spending actually a lot of time on this, working with a lot of communities on how to build that authority having jurisdiction to make sure the community, because they have the fiduciary duty to ensure that the home is built properly and to stop members suing chief and council for poorly built homes that aren't safe. Hey, Claude.
Great, thanks, John. Certainly, as John has mentioned, we've done a lot of work on this whole issue of authority having jurisdiction, but getting back to building code. Well, everyone involved in construction buildings must be familiar with the practical application of building code documents. If we want to build better and have homes that last, they should, at a minimum, follow building code. Certainly I won't say every province has it or every territory has it, but a fair number of the larger, we'll call it more populated provinces, Alberta, BC, Ontario, Quebec, have their own, we'll call it flavor. And basically what they've taken is the National Building Code and kind of retweaked it to suit their provincial standards, we'll call it. So for the most part, it's pretty much the same with a lot of, well, not a lot, but a fair amount of additional add-on that applies. For example, I'm in the province of Ontario. So again, then it becomes the Ontario Building Code, but it's basically the model code that it's developed from is the National Building Code of Canada. So they don't have to rewrite it totally. National Building Code's already there. It's retweaking it, like I say, and adding in their flavor to suit their particular provincial needs. Well, let's talk about this training session. Well, the training session really, this is simply a webinar introducing a little bit about the building code. As I mentioned earlier, I could spend 40 hours talking about building code in a building code course. And in fact, in the province of Ontario, we have probably in the range of 10 different building code courses that apply to a number of different, we'll call it areas of the building code. And probably a number of you are getting very familiar with Part 9 of the building code. I like to call that the small buildings or the residential or the house or the dwelling side of things. So really, we want to get a better understanding of what is the building code and how to use it. But a couple of things we have to think about is, and I've highlighted those in sort of that burgundy color or deep, we'll call it red color, interpretation, the implementation, and enforcement. John touched a little bit on the enforcement, and certainly implementation means it has to be accepted by the local community. As John indicated, I live down near Windsor, Ontario. Actually, where I actually live is called Lakeshore, and it's a little different building department that's not associated with Windsor, but they have, again, a permit process, inspection process, and you have to have all the I's dotted and all the T's crossed in order to build and meet certainly the building code standard. But really what this is all about when we talk about codes and why are they really important, we want longer lasting, safer, better building practices so that we have houses, and not just houses, buildings in general, that are going to last for many, many years, not a short term that often we hear about in a lot of First Nation communities. So let's move on and we talk about a little bit of the building code. Well, there's some technical requirements, and again, I might have touched on a few of these, but it sets out technical provisions for the design and construction of basically all new buildings. It applies even to alteration, change of use, and demolition of existing buildings. So again, a friend of mine bought an old church and she converted it into, we'll call it a wedding venue, okay, an event center. And it basically had to go under what they call alteration and change of use. So again, different parts of the code apply to different types of, we'll call it, in this case, existing buildings. We also want to take a look at what are really some of the key issues, and we take a look at what are the objectives and the requirements, and why do we have a national building code? Well, we can see the 5 bullets here, or points here, is safety, health, accessibility, fire and structural protection of buildings, and certainly the environment in general. So even with the environment, we could start talking about issues such as thermal efficiency. That's a requirement to help reduce or heating and costs of basically living in a house. We also have to tie in and take a look at, there's a relationship between the National Building Code and the NFC, which is the National Fire Code. So although the National Building Code does talk about fire and safety and things such as smoke alarms and basically fire detection devices in larger buildings, there also is the National Fire Code that goes into a lot greater detail. Again, there's a bit of repetition between the two, but the National Fire Code goes into a greater depth when it comes to the fire side of we'll call it buildings. So the NBC covers fire safety and fire protection features that are required to be incorporated into a building at the time of the original construction. Building codes typically no longer apply once a building is occupied, unless the building is undergoing alteration. So as I mentioned, as change of use happens, then it has to comply with maybe a higher level of standard. Certainly in the previous case, I talked about a church becoming an event center. Both have a lot of people that are going to occupy that building, whether it's a church or an event center, but they're kind of different functions. So there's different requirements. We'll call it in the case of what I would call a part 3 of the building code. But my primary focus really isn't on going into a lot of detail, certainly on part 3 of the building code. We're going to focus mostly on part 9 of the building code. Again, when we take a look at some of the building code, we have to talk about the 2 main divisions. Earlier building codes didn't get into a lot of detail other than saying, this is what you need to do in order to have acceptable solutions to meet the code. Well, in Division A, we can see compliance methods, the objectives and functional statements. Okay, functional statements are sort of, okay, why do we need fire protection in a building? Why do we need bathrooms in a building? So that's about health and certainly, accommodating people that are going to be using a building. So the objectives describe the overall goal that code provisions are intended to achieve, such as safety, health, and accessibility, fire protection, and again, the environment. The functional statements describe the conditions that help satisfy the objectives, such as structural integrity, fire separation, ventilation, and insulation. Now, for the most part, if we're just dealing with, we'll call it the house or a dwelling, we're really not going to be focusing too much on really Division A. We're going to be talking about more of what's probably going to fall under what's called Division B. What are those acceptable solutions? They meet the objectives and functional statements of Division A, but these are well-known, we'll call it past experience in history of what works and what functions well when we talk about building code and doing it to a good building standard. So as I mentioned, the building code is divided into 2 volumes, 3 divisions and 14 parts. Wow, that's a lot of stuff to really look at and study. So like I mentioned before, having taught in the college system, we did a lot of building code courses for the architectural, the engineering, and certainly the construction students when it comes to building codes. They need to know and understand how to use them and how to put them to use. And certainly you can see there is a lot of information within those 2 volumes of the National Building Code. Another thing we need to take a look at is when we start reading and looking at it, we need to look at how is it put together? Because this might be getting down to the basic grassroots without getting into a lot of detail, but we need to understand how to read the building code. So if we want to call it navigating that building code, it's based on a decimal type numbering system used to identify the sections and subsections of the parts with various heading and highlights for specific requirements. So I say, let's review what this entails in the following activity. So if we look, for example, at part 9.5, so this is part 9, okay, section 5, it's called design of areas and spaces. So if I was going to design a house or a building, it gives me some information in this particular section of the code. So it's broken down into, you can see further parts, 9.5.1, general, it talks about the subsection. So it's going to give me some general information. Perhaps it says something to the effect of the design of the bedroom must be this specific size, or the ceiling height must be a minimum of this particular height. So again, this is the subsection portion. And then it talks about 9.5.1.1 method of measurement. And this is getting down to articles. And as we can see, it gets down to combination rooms, article 2. And if we want to talk about barrier-free design, again, another subsection. So 9.5.2 would be similar to 9.5.1 with a series of, we'll call it articles listed below it. So again, just getting familiar with how to read and what all this means when we talk about all these code parts and subsections. In my past experience, we've had students that want to become what we call the building inspectors, or maybe want to pursue their career as a building inspector working for the local municipality. So when it comes down to exams, they need to know about what does it say and where do I find it? So it gets down to the level of this, we'll call it this decimal numbering system. So for example, if it was just simply on barrier-free design, they would have to give an answer plus a reference. 9.5.2 is where I'm going to find that particular bit of information. Well, again, let's take a look at the table of contents. So when we take a look at the table of contents in the building code, it is, again, a lot of information. So Division A, compliance, objectives, and functional statements. And we can see it's divided into various parts within Division A. So I'm not going to go through the whole list here, but we'll just say, let's look at Division A, Part 1, compliance, Part 2, the objectives, and Part 3 is the functional statements. So again, this is kind of a general overview of when we take a look at the table of contents. Division B, acceptable solutions, and Division C, administrative provisions. So when we talk about Division C, we're talking more at the administrative level of things. But going back to the Division B, the acceptable solutions, that's the area that we want to focus on primarily when we're talking about understanding National Building Code. So if we slide all the way down from Division B to just above Division C, we see Part 9. I don't know why it's duplicated there, but Part 9, housing and small buildings. That's going to be our primary focus. We talk about National Building Code in this particular group setting. So again, just some general information, table of contents. And by the way, towards the back of each volume is also an index. So we could look up a word such as barrier-free, or soil, or fire separation, or firewall, or something to do with plumbing or heating or structural design. So again, just to kind of as a general reminder to think about, there's a lot of different ways of looking at this. So table of contents, again, compliance objectives and functional statements. So in Division A, I said a lot of times we're probably not going to get involved with this unless we're really working on the level of an architect or an engineer. Includes compliance options and information on objectives and functional statements. So within the building code, there are a bunch of functional statements, as I mentioned earlier, perhaps something like fire requirements. Objectives describe the overall goals that a particular code provisions are intended to achieve. So again, it's a goal. What's the goal? Is certainly when we talk about fire, is fire safety. How do we achieve it in any building? So functional statements describe the function that a building or its components must perform to fulfill those objectives. Well, here's an objective statement. So for example, OS, okay, objectives, OS stands for objective statement, abbreviation safety. An objective of this code is to limit the probability that a result of the design, construction, or demolition of the building, a person in or adjacent to the building will be exposed to an unacceptable risk of injury. So again, that really doesn't tell us a lot. It tells us about the objective, but it doesn't tell us how to do it per se. And it goes on, you can see one on fire safety. So the example on fire safety talks about different articles within it. So concerns for fire explosion occurring, impacting areas beyond its point of origin, the building next door, people next door, or collapse of physical element due to a fire explosion. So we can see these are all sort of nice objective. Okay, this is what we want to achieve, but it doesn't tell us how to achieve it. So that's where the architect or engineer would have to come back and basically build their, I guess, their hypotheses of how that would be accomplished. So again, we don't want to get too tied up with that, but it's good to understand what that part really means. We can't ignore it, but at the same time, we have to understand a little bit about what are those objective statements all about. And again, sample functional statements. So we talk about function, minimize the risk of accidental ignition, limit the severity and effects of fire explosion. And again, getting into a whole different level of detail. So for the most part, I would say you really don't want to be overly concerned with this if we're just simply talking about training people on good, we'll call it good construction based on code. We can kind of bypass this. But again, it's just sort of good background information. Acceptable solutions, okay, it's kind of the same thing. But let's get down to sort of the nitty-gritty. Division B, acceptable solutions. So we talk about the acceptable solutions, now referred to, it used to be provisions in the past, acceptable provisions is now called acceptable solutions in the 2020 version. Actually, 2015 called it also. So it's the more recent versions relating to such issues as fire protection, occupant safety and accessibility, structural design, environmental separation, heating, ventilating, and air conditioning, plumbing services, and housing in small buildings. So most code users typically are going to be using Division B. So this is our key area that we're going to focus on, or we should be focusing on. Excuse me. The technical requirements. So again, this is a clip, okay, an image copied from the National Building Code and talks about Canadian standards. Many of the standards referenced in the National Building Code are published by standard development organizations accredited in Canada. So again, without getting into a lot of detail, what we have to realize is that there are testing standards and there are basically product standards. And for example, heating and refrigeration when it comes to heating. When we talk about testing standards, well, we see testing standards such as the CSA group. CSA, for example, if we take a look at a CSA label on anything electrical in Canada, should have a CSA label. So it's met a standard for compliance for use within a building or in a building condition within Canada. ULC is Underwriters Label of Canada. That's a fire rating. So a fire rating of doors as an example, or fire rating of building materials. So again, there's a number of different standards. Canadian General Standards Board. And again, there's certainly the, we'll call it the Francophone Bureau de Normalisation du Quebec. So there's a number of different standards out there. These are all brought into the building code and referenced in the building code because these are proven standards of accreditation. So in other words, universal recognition within the country. Similarly, the same would apply in the US when it talks to their building codes, but not necessarily to the Canadian standards, but to the American standard equivalent. Well, when we talk about technical requirements, we talk about also certification. So certification is the conformity by an independent organization that a product, process, or service or system meets the requirement. So it's a physical examination and testing of the product. So we talk about places such as the National Research Council of Canada, and similar bodies like that that are actually testing materials or products on the market, be it a solar panel, be it a solid wood framing, be it a type of screw pile for a foundation system. There are testing standards and certifications that are out there. Of course, the building codes want to refer to those because Canadian Construction Material Center, CCMC, at the National Research simply offers product certification services. Certainly, there's a fee that's attached to testing because it's a very intensive and certainly time-consuming process. But again, these are all proven facts that back up and basically support the reason why we have national building codes or building codes in general across the country to build. We want things to last and be proven to be good products that will stand up. Well, let's get back into a little bit of the building code. That was a little bit of sort of the background of what's going on within the building code. So part one talks about compliance. So again, I've cut out a portion here. So just sort of a cut and paste on the screen here. So the application of the code. So when we read about the application of this code, it says, except as provided in sentence bracket 3, this code applies to the design, construction, and occupancy of all new buildings in the alteration, reconstruction, demolition, removal, relocation, and occupancy of all existing buildings. And then there's a reference to C note A-1.1.1.1 bracket 1 and so on. So what we have to do when we take a look at application is basically saying it applies to all buildings, all new buildings, and alteration, reconstruction, and so on as we go through that article. And there could be some things such as some exceptions. So for example, in bracket 2, article 2, except as provided in sentence bracket 3, this code applies to both site-built and factory-constructed buildings. So even a off-site build brought to the site and put on the site, it certainly has to comply with this code. The question is, does it? But we'll get into that with another topic at another time. Or farm buildings not more than 3 stories. So again, you can see there's different applications of this code. Does it apply to farm buildings or not? So that's really what is being brought up here when we take a look at compliance for section 1.1. So application of building code. Okay, let's talk a little bit more about materials, appliance, systems, and equipment. So again, when we're in part 1, by the way, and we're talking about compliance, it says that all materials, appliances, systems, equipment installed to meet the requirements of code shall possess the necessary characteristic to perform their intended function when installed in the building. So for example, we would have to assume that all materials are new, not necessarily used. The systems are intended to function as they were required to actually function. Okay, and they have the necessary characteristics to perform their intended function. Storage on the building site, well, basically they basically are saying, well, when, let's say, a load of lumber is shipped and you're going to start stick building a house, it should be basically protected. So you will see in 1.2.2.2 bracket 1 is saying prevent the deterioration or impairment of their essential properties. We don't want wood to sit there and rot because it can't be, let's say, constructed until next year. So it has to be protected. So again, we see some issues within the building code that say, well, again, it raises the question, who's going to enforce this? Well, off reserve, we know that this is enforced, not 100%. Things can slip by. But for the most part, a building inspector could even, let's say, John mentioned the word stop work order. Well, that's old crappy material that's no longer good for the purpose intended. So you can't use that stuff. Okay, stop building. It doesn't meet code. Used materials, appliance, and equipment. Similar, there's a commentary about used materials, appliance, and equipment. So again, when we talk about compliance, and compliance usually refers to the fact somebody's there to enforce that. We like to look at it when we talk about off reserve. It's almost like policing powers. It's a legal it's a legal application of the code is similar to the policing powers of the police force. Okay, let's determine some relevant code parts though. So when we're talking about looking at code, we have to think about what are the relevant code parts. So how do we determine this? Well, first off, if we're looking at any building, whether it's a house, a church, a community center, whatever, determine which part of the code is applicable to that specific building. So again, we have to kind of hunt for Waldo through the building code and find out what really applies to this particular building. So in our discussions, we will mainly deal with Division B. Okay, we talked about that. Well-known experience from the past for multiple versions of the building code for Part 9 housing and small buildings. So this applies to the design and construction of buildings used or intended for residential occupancies, business and personal services occupancies, mercantile occupancies, medium low hazard, no high hazard here. That's part 3. Industrial occupancies for buildings that do not exceed, and here are some of the key criteria: 600 meters square in building area and not exceeding 3 stories in building height. And the stories in building height is again defined in the building code. So within the building code, when we talk about mercantile and dwelling in stories, these are all definitions defined within the building code. So we get a better understanding of what these terms exactly mean. So we call it the language of the building code. So again, the language of the building code can be a little bit confusing. I used the word house earlier, but in the building code, they tend to call it not so much a house, they call it more of a dwelling. So I guess a place where people would live, or understandably would be living. Well, let's take a look again at some relevant code parts, and let's apply it to the Division B. Well, when we take a look at the application, okay, so we want to apply Part 9 to what type of the building? Well, it applies to certain types of buildings. Well, we can see that if we sort of ignore the burgundy color for a moment, Part 9 of Division B applies to all buildings described in Article 1.1.1. We went way back at the beginning, that Article 1.1. Okay, 3 stories, so there's our height. Our size over there, okay, building area not exceeding 600 meters square and used for the major occupancies classified as. So now we get into what's called the group. So when we call in the grouping of buildings, there are different groups that are defined. So for example, Group B is a home type care occupancy. Home type care could be a nursing home. Group C, residential occupancies, a house or a residential type structure. D, business, E, mercantile, and F, medium and low hazard. So again, these are a few sample, if we take a look at the drawing to check, let's say, the National Building Code for compliance. So let's say that we have a set of drawings in front of us, and let's say, for example, it's that, that 6 unit that is being proposed in your community. We're going to say, well, it's a Group C residential occupancy. It's only 1 story in height from what I saw from the drawings. But does it exceed 600 meters square, or is it actually less? So 600 meters square, I like to just round it off and say in Imperial System, a little over 6,000 square feet. Well, if it falls within being under that, Part 9 applies, and it's considered Group C, and it's met those sort of checks and balances. Again, we can use some other information to help us. So here's a part of that floor plan of, actually this is the 4-plex, not the 6-plex. So when I take a look at this example, I can see it's 99 feet long overall. It's 34 feet in depth from front to back. Yeah, it has it has some porches on the front, so we'll call them little covered porch areas. And when I take a look at it, and I'm looking at the building code, it's certainly a Part 9 Group C type occupancy. So I can start to take a look at this, and I can start to use the building code and apply the building code to make sure that what I see and what's going to happen, hopefully, on the construction site is going to be able, if we're going to build it to code, it's going to comply with the building code? Well, right off the bat, we see that it does comply when we take a look at the general configuration for size, height, in sort of those area requirements. And it does fall within that Group C category of being basically a residential type occupancy. So these are important details we can look at. But there's a lot of other details we can look at when we talk about a set of drawings. And actually tomorrow's session, we're going to deal a lot more with, we'll call them the blueprints and drawings as the next session of the webinar. But for example, we could talk about windows and doors are defined in the code. So windows and doors. But what about in the bathrooms? Well, we see in the building code, when we take a look at the plumbing section, it has to have certain features to meet the National Building Code. It needs a kitchen sink. It needs a toilet or a water closet, if you want to call it that. Again, terminology. A tub or a shower. We have a vanity with a sink. So we have met all the requirements when I look at this and I take a look at the plumbing side of things. I don't have a lot of detail of how the pipes and the drains and everything's going to be connected to it, but I see when I look at a set of plans, it's got the things necessary to meet building code. I could take a look at it in more detail and say, well, when we talk about spaces and areas, does it have to have a closet or not? Well, the code doesn't say it has to have a closet. It's nice to see there's closets here, which is good. But are there requirements when we come to the area, for example, of those bedrooms? Does it have to be a certain size? Well, again, we can look into the building code and determine if that's true or not, or does it apply? Some of the old building codes did apply that it had to have a minimum square footage or area. The newer building codes say, well, you know, a space is a space is a space. You know, we're defining a bedroom as a bedroom. Well, what's stopping somebody from saying, well, that's my office? Boy, or the living room is no longer a living room, it's just an open family space. So again, the terminology gets a little bit conflicted, so they've kind of drifted away and made changes that let's drop the specific, we'll call it floor area requirements, and just take it for what it is. Well, that bedroom number 2 is smaller than bedroom number 1 or room number 1, but notice they call it room number 1, not bedroom number 1. So does it really matter what that space is defined for? So again, we take a look at it from the building code perspective. In between each unit, we have this double wall system. Well, when we take a look at detail 3.3 down here in the construction details, this is what is in the building code called the fire separation. A firewall goes up above the roof and is usually for a building that exceeds 600 meters square. That's how builders get around that. We'll call it the 600 meter square rule for residential. In this case, we have 3 separate fire separations. Now the fire separations, again, if we read code, must go down to the lowest level, foundation system, and right up to the underside of roof. So again, this is all in building code. So again, when we get into the construction, I'm jumping ahead from thinking about construction to what does a code say. And if you really think about it, isn't it all kind of interrelated? Code, drawings, what's designed, how it's designed, and does it actually meet code? So again, this is just one example. So I'll move on to the next one. Let's talk about elevations. Well, we don't really talk about elevations in building code, but we do talk about materials that impact drawings in elevations. So for example, we see there's vents on the roof. We see there's windows and doors. In this particular elevation, we see sort of the front doors, the porch, the windows, kind of the type of windows indicated by architectural symbols. We see the roof pitches. So we get some general information. But other thing that we need to know, for example, is the depth of footings. So we can talk about the foundation system and take a look at it according to building code. So when we take a look at things like this, we can tie it back into building code and drawings, and they're kind of interrelated. We see over here, it says treated wood railings. Well, yeah, it's outside. It should be pressure treated because it's going to be weathering the storm, we'll call it, through snow and rain and so on. So again, the general information that we see on drawings, when an architect or an engineer or an architectural technician puts drawings together, they're typically going to be referencing building code. They have to understand building code. Likewise, hopefully the builders in the field understand building code. Unfortunately, that's not always the case. Not trying to put builders down. Some do a great job and some, well, might not do such a great job. Another drawing within the set that I've been reviewing, okay, for the fourplex is this set of drawings. And this shows us some of the construction details. So for example, when we talk about footings, so the footings down here, the drainage tile. Oh, and by the way, there's these 2x2 rigid insulation. What is this all about? It's 4 inches thick. Well, again, we have to understand a little bit about construction and what is actually happening here. So when I take a look at what the designer has presented here, this is actually frost protection. Okay, this is an engineered solution to protect footings from frost damage. So that's what this is. Code says it doesn't have to be there, but it is. So whoever designed this did a great job in trying to protect footings and foundation system. So again, you can go above the code or hopefully meet at least as a minimum, what does the code require? So again, I'm not going to go through all the details here, but just some general information about this is the wall section of the outer wall of the house. How well is it sealed? Okay, so I see urethane around the window. So they certainly want to seal up that window because understandably, windows and openings in an outer wall can be vulnerable areas where if they're not done properly, we could end up with wood rot down into this wood framing below. We see layers of insulation in the wall and on the outside going towards, we'll call it the exterior sheathing. Again, this is going to reduce, remember I talked about thermal bridging? Well, this is how you reduce thermal bridging. You put the insulation on the outside. This outer layer of insulation is going to reduce the cold transfer through a wood stud, causing ghosting on the inside of a house. Wow, we just took care of some building science, but we also did it in a good way through proper good construction detailing. Now, when I looked at this, it raised a question. I think this is a really, really good section. This is the fire separation between two units. So when I take a look at it, we see this is solid concrete, it's insulated. It's insulated, a double wall system with an air space in between, which is proper, going all the way up to the underside of the roof. This is a fire separation. Well, what's happening here is when I read this, it says two gypsum board, 5/8 type X, painted with 3 coats. I think this is great, but this is overkill. But that's only my personal point of view. I was talking about this detail with John the other day, and I was saying, this is an area where they could either save some money, or maybe there was an intended purpose for the double layer of 5/8 gypsum board. So when I read the building code, it actually says it only needs 1 layer. In fact, it doesn't even need to be 2 layers unless somebody wanted to simply add extra protection here. But the ironic part of it is, if you look at it, well, that's great until you get up to the ceiling is single, and up in the attic space between is only single also. So it might be a means of saving money or just extra fire protection, that if there was a fire on the first unit, it's not going to spread too easily into the second unit. Again, I don't know the rationale behind it. I'm not the designer. And I'm not to say the designer's right or wrong. I'm just saying, when I look at it from my point of view, certainly it meets code and it's a little bit above code.
Claude,
Yes.
Dale knows why we did that.
Okay, thank you. Please. Okay.
Yes, please.
Did you want to?
He said for the airspace.
Oh, okay. That's good. I'm not going to doubt that for a moment. So it's good to understand, because sometimes we see a detail like this and sometimes you say, oh, this goes beyond, but you know what? The building code says you can't go, there's nothing saying you can't go above the building code. That's going above is always better.
But I like to save money, so you got me questioning that.
Okay. We can talk about it in further detail later. And again,
Yeah.
and again, this is a plan detail of basically at the outer wall where the two connect, the fire separation to the outer wall. But again, just taking a look at some detail here. So what I did is in this particular slide, I compared two different projects. This is the one for the fourplex, and this is the one that First Nation Building Officers Association are offering as a set of house plans. That is for, we'll call it extreme northern exposure as far as construction is concerned. So I just wanted to kind of point out that this is way above building code, but whoops, way above building code. I have to go back a minute here. Whoops, there we go. This goes way above building code, but that's a good thing because it is for extremes in, we'll call it very extreme cold temperature regions. So when we take a look at it, we see a single, we'll call it 2x4 or 2x6 stud construction with insulation and outer insulation. But when we take a look at this, we see a double wall system, okay? Well insulated and very, very thick. Take a look at the difference. And I know it's hard to say they're two different scales, but this wall is going to be almost 12 inches thick. This one over here is going to
ask a question. Sorry.
Yeah.
I'm just wondering, when you say cold temperatures, what is that? Is that in the building code, or who categorizes that temperature? Like,
okay, so the temperature that you're going to design when we talk about building code is compliance for your particular, we'll call it climate zone.
Mhm.
So we could talk a little bit about climate zone, because within the building code, there are climate tables within the building code. So if you look up, let's say, I tried to look up, let's say, Temiskaming as an example in the National Building Code, and it doesn't show me the climate zone, but it does show me North Bay. It does show me other areas close to it. We can determine how much insulation is required as a minimum in, let's say, the wall over here, as opposed to the one for the wall over here, which is on an extreme northern climate, which I'm talking about getting up into the Northwest Territories. So all we see is two differences. Something like,
Don't forget to also mention about the Hot 2000 program.
well, yeah, and that's another part is when we talk about the thermal efficiency, this goes beyond code. So we're getting into what we want to call what net zero and Hot 2000. So getting into building designs where the code is going is the codes are targeting higher thermal energy efficiency in buildings, whether it's a house or whether it's an office building. So
And
again,
so Hot 2000, what it is, it's a program that's ran by, I guess,
Enercan.
yes, they own by Artican, but engineers or architects run it, and they can tell you specifically how much insulation you require in that house and where the insulation should be in order to achieve net zero or to reduce your energy costs. So in this case, it says you need X amount of insulation versus where Claude lives, you don't need as much insulation. And it talks about the windows, right, Claude? It goes into 3 pane versus 2 pane. So the modeling will tell you exactly how that house should be built for energy efficiency.
Yeah, you're right, John, because this shows me over here on the fourplex, it's going to be a double glaze window. Over here we're talking about a triple glaze. We can talk about what we see here is a lot more insulation when we kind of blow up the details. We can see multiple 2x4s. We can see this is basically a 2x12 sill plate. Over here, we're probably lucky if we're getting a 2x6 sill plate. So certainly a greater impact, but again, we can do comparisons. It's not fair to do a comparison from two different climate zones because, this could have been a lot simpler than, let's say, what we see over here.
Yeah.
So again,
And,
it's
and
just,
the other point to add, when you do a hot 2000, it's going to increase your construction cost because it's going to say, 2-ply versus 3-ply, more insulation. But in the long term, there's substantial savings by the amount of energy and life cycle of the house. So you pay more, but you save substantially more, I think, after sometimes, and they tell you after 7 years, 10 years, how much your savings will be in terms of energy efficiency.
that's right, John. So what you see here is this house has not been energy modeled, and that's the way the codes are going, is towards more energy modeling. But over here we can see, even here we have triple layer of insulation in the attic, as opposed to, let's say, maybe a double layer over here. So again, everything's exponentially greater in this particular drawing or construction detail over to the right-hand side as opposed to the left. So again, I just wanted to kind of point that out because when we talk about building code and getting back to the issue of climate zones, we also have to understand where we're building. So how much insulation should be the minimum in the wall? Do we need to provide for heavy structural, let's say, roof construction because there's greater snow loads? Because snow loads can be pretty huge when we know the further north we get, greater opportunity for snow buildup on a roof, as an example. So kind of moving on, when I was teaching, certainly my architectural students, I used to use something like this. Obviously, we use the Ontario Building Code data matrix. So what I'm showing you here is something from the Royal Architectural Institute of Canada, the Architectural Institute. And it has up here, it kind of cut off as part 3 and part 9. And it kind of you could almost kind of use this as a checklist. So you could describe the project, what's a major occupancy, what's the building area. And what it does is it's a nice quick checklist that I could say to the students, well, if you want to check the building code on building area, go to this part over here. So part 1, 4, 1, 2, or building area, if it's a house, if we take a look at major occupancy, which we looked at earlier, 9, 10, 2, well, that's where the reference is. So it kind of gives us a guide to where to look. We could talk about, are there sprinklers required? Well, no, there's not for residential. Is a fire alarm required? Well, not unless it's a multiplex, we'll say larger residential structure. What type of construction is permitted? So you see here, permitted construction, combustible, non-combustible, or a little bit of both. And where does that derive from is 910.6. So I'm going to jump over to this side of the slide, and 910.6 is construction types. So 910.6.1, combustible elements in non-combustible construction. So what we have to understand is when we talk about combustible versus combustible, will it burn or does it take a lot longer to burn? So concrete takes a lot longer to be destroyed by fire than wood, and so on. So we're talking about combustible versus non-combustible construction when we talk about building codes. Well, we know that most houses, most residential buildings, a lot of Part 9 buildings are largely wood frame structures. So this is really a combustible building material. So again, we fall into the combustible area. If it's non-combustible, it could be, like I mentioned, concrete, could be concrete block. So there's other products obviously out there that are less combustible than wood. So again, heavy timber as an example. So if it was a heavy timber under 910.6.2, okay, shall be considered to have a 45-minute fire resistant rating, okay, to be considered heavy timber. And of course, heavy timber, as we know, are large size wood members. It's just not a 2x4. So I wanted to talk a little about this so that we can use this checklist to kind of say, well, if I was checking a set of plans, I would use this checklist to say, okay, is this building okay? And it can be combustible construction if I look at the code. Occupant load, well, I'm not worried about occupant load because that's talking about larger buildings such as, we'll call it the community center or a church or something. Does it have to be barrier-free design? 952. Oh, what does 952 say in the building code? Does a house have to be barrier-free? Well, the answer is no, but it can be. Okay, so where do I find and prove that theory? So in the building code, it says barrier-free design, except as provided in 9523, every building shall be designed in conformance with section 3.8. Well, we're going to jump down to 3.8 a little bit further down here. Protection of floor areas within the barrier-free path. So in other words, we want to make sure that people get out safely, and there's exception for apartment buildings. And I'll just finish off, and I think Tanya had a question. Well, when we go to 3.82, there are some exceptions. So this is where we get excluded, and we don't have to make a house barrier-free. The requirements of this section apply to all buildings except detached houses, semi-detached houses, houses with secondary suites, duplex, triplex, townhouse, row house, boarding house, blah, blah, blah. So as you can see here, if I'm using the building code, I can say, I can argue, or I won't say argue, I can really clearly say a house does not have to be barrier-free. Should it be? Well, I agree there should be some barrier-free homes, because let's face it, there are elders and people that are going to be challenged with just living in, we'll call it, what I would consider just a regular house without some barrier-free design features. Tanya, did you have a question?
Yeah, I'm just thinking of, so I look at concrete as non-combustible element, right?
Yes.
So I'm going to give you an example. We build basements, and one of the requirements, and I haven't found that, but is to put drywall on the interior of the wall. Like when we finish a basement, we can't leave, and even a crawl space, they're requiring drywall on the interior wall.
Oh, is that right? Yeah,
But
I
is that
thought,
in the building code? Is my question.
not to my knowledge, no. I mean, I mean, I could understand it from a fire protection point of view. I suppose the only part I would be concerned about is any exposed wood construction. Now,
Okay, so maybe it's, I just realized that. So maybe it's only when we do the styrofoam insulation.
yes,
walls.
if there's styrofoam insulation, the insulation according to building code must be protected because it's highly toxic and certainly going to cause a lot of, we'll call it, certain concerns with health, because as soon as we'll say fire or heat hits that, it's a black toxic smoke. You know,
Okay,
so if there's insulation on the inside of the foundation, yes, it must be covered with a protective barrier, and certainly gypsum board would satisfy that requirement. The other area when we talk about building code also is, are the floor joists traditional, let's say 2x10s as opposed to engineered lumber? Because if it's engineered lumber, that must be protected by basically gypsum board also, so drywall.
so that's the what you did there at Justin Jacobs. It's engineered floor joist. That's why it's covered with drywall. Okay,
Yeah,
we just went through that right now because I didn't know why we had drywall in the crawl space on the ceiling. So that's what it was, because it's engineered floor joists.
the problem is they consider the wood, the engineered wood trusses, they're not solid lumber. So therefore they burn a lot faster than, let's say, a 2x10 would.
Okay.
So,
Okay.
by the way, that is more recent codes that have caught up with, we'll call it fire regulations. So the fire codes, because what happened, there's a little history to it, is the fire department in many areas got concerned with the fact of injuries caused to firefighters falling through an engineered floor system. So in other words, let's minimize and basically increase the fire protection to that type of floor system as opposed to solid lumber. Okay. So anyways, just kind of moving on, you can see that when we jump around with building code, there's a lot of different things we could look at and study. So again, John brought up the issue about radon yesterday, and actually I brought it up and John commented on it. So again, I thought, well, you know, this is something I haven't looked at in a while, is what does the National Building Code say about radon? And it does say something about radon in the building code. More recent version, excuse me. So they call it soil gas control. Well, soil gas is basically another word for, in this case, radon. So we can see that under 913.4, under soil gas control, we see there's a whole section here about protection from soil gas ingress, okay, coming into a conditioned space. Whether it's a crawl space, it's a basement, or the house in general, that's a conditioned space because we heat, hopefully cool, ventilate it, etc. So when we take a look at the building code, it certainly has all that legal language up here, but it says all wall, roof, floor assemblies separating conditioned spaces from the ground shall be protected by an air barrier system. Got it. Unless the space in the ground is designed to be accessible for future installation of a subfloor depressurization system. And this is where we see here, if we take a look at the building code, it gives us acceptable configurations for extraction of openings and depressurized systems for radon mitigation. So again, this is just a rough-in. This isn't the whole system. This is just put it in new construction because it's not very, very much money at this stage. But certainly if we had to tear up a floor and put it into an older existing house, it means basically opening up a good part of the floor to put the system in. So the building codes nowadays in most of Canada pretty much say, hey, why not put it in now in any new construction, even if you don't have a concern with radon, but the code says, yeah, you should put it in because it's just a good safety measure.
Do you guys have radon in your community, Tanya?
I believe we do, but we've never put in systems with that.
Right.
So in the future, it might be something to think about. Certainly, I mean, certainly testing proves whether it is or isn't an issue.
Yeah, we've never had it really tested here that I recall.
Yeah, the numbers that I came up with said it was over 200 from what I can find by postal codes analysis. It's high.
Really?
Yeah.
So 200 is high? What's the, that's what it says for our area, 200?
Yeah, it said over 200. I gotta see if I can find specific numbers. I know some communities that have 6, 7, you know, that's a lot. Like that's a health hazard.
Okay, because we're, like, I just thought because we're on bedrock here, so
Oh, that's even more so. Radon comes up through bedrock.
I know that's why I figure we probably do, but
Yeah.
yeah,
We
definitely
actually
something to look at.
we have actually radon readers. Maybe Chloe, we gotta maybe bring ours up and just
Yeah, we should bring ours up just to do maybe some just sort of, you know, spot checks if you like.
yeah.
Sure.
So again, just maybe to kind of wrap things up towards the end here is the illustrated user's guide. Well, the illustrated user's guide is really, it's not building code. It's an interpretation or a guide to help code users understand and apply provisions of Part 9 of the building code. So when we take a look at it, you know, it has no legal status. So you don't really need to adopt it as such. It's really just sort of a good guide reference book. So it's solely informational. Certainly, there's a lot of sketches and diagrams that are going to help people understand the building code. So for example, that previous illustration here helps us understand what's required in a way of doing it, as opposed to just reading over here every bit of chapter and verse of what it tells us by the building code. So for example, there's more information, 913.4.3 on the bottom here has more information. I just sort of clipped off some of the more important parts. Okay, if there are areas in the guide that conflict with the building code, certainly the building code is, we'll call it the legal power of authority. It really governs. So again, I tried to use an example. So illustrate a user's guide, a pretty common area that right from the start, when a builder is starting, is a footing. So when we talk about footings, we have to be concerned about how deep is it going. It has to be protected from frost. And the frost levels can be determined from that climatic zone chart again, which is in the building code. It gives us insulation, amount of rain, amount of snow on average. So those are all factual information designers use for design of footings, indoor for, we'll say, roof systems and so on. But anyways, moving on, if we take a look at the illustrated user's guide, this over to the left is building code. So from the National Building Code, foundation conditions, and it talks about allowable bearing pressure. So when we talk about allowable building pressure, we have to think about this footing over here, bearing down on whatever soil there is. Okay, they want to know, okay, what's the bearing capacity? So it has to have a certain bearing capacity. Otherwise, if it's weak, this building is going to settle. And we don't want buildings to settle. We want them to be on reasonably firm, solid ground, so they're not going to settle. We don't have all kinds of cracks and other conditions occur. So over here, again going back to 944 of the National Building Code, it talks about, this is only part of foundations, is foundation conditions. We can see here footing sizes for shallow footing shall be determined according with section 915 or designed in according to section 4.2. Well, if we go to section 4.2, we're going into structural engineering, which means hiring an architect or an engineer. Well, we don't necessarily have to do that, because if we take a look at allowable pressure for soil on rock as an example, or different types of soils, so we can see here the different types listed: clay, soft clay, dense, compact, silt, sand, gravel, etc. We see the allowable bearing pressure. Well, the allowable building pressure is also defined in the building code. So again, we can use that as our comparison based on the type of soil that is in your particular area. So that's code side of things, which is kind of gets a little bit,
So Claude, just to interrupt here. So to determine the pressures, this is where you need somebody to do your soil testing, right? This is why they require soil testing to come in to determine this?
Yeah, yes, you can, but let's say that the acceptable bearing in your particular area is 70 kPa. So that's 70 kilopascals. So let's say if we take a look at any of these, all of these are above 70, which is great. So all of these are good. But loose sand or gravel, whoop, it's at 50. I can't go on loose sand or gravel. If I got loose sand or gravel, I need an engineered system. Oh, what about soft clay? It's at 40. That's even worse. So if we take a look at different soil conditions, if we know even just without going to the soil engineer that our area has, so for example, in my area, I have a lot of firm clay. So I'm at 75. Okay, if I go to Sound Rock, wow, 500. Clay shale, 300. So again, we can see these larger numbers are certainly going to support a structure very well, but it presents other problems if we're dealing with rock with our foundation system.
So what we found in so building in northern Saskatchewan, and a lot of the indigenous groups who are now starting to do soil testing.
Yes.
They're actually built, if you go to northern Saskatchewan, there's actually sand dunes up there. Matter of fact, the same sand that you have in Africa are in the Athabasca sand dunes in the north. And when they build on there, they have this issue of loose soil and gravel. And in many communities, they don't do compressions. And as a result, using the Paul Simon slip sliding away, it just starts crumbling and moving around. So they're now becoming more diligent to use engineered soil testing, as well as if they're doing piles, they go in substantially more deeper than generally is required.
Yeah, yeah. So that's where you would, it certainly would be highly recommended, certainly to have even periodic testing. Because let's face it, even within a specific, we'll say property or area, soil conditions can change. We don't know. And I know, having worked in the architectural and engineering field in the past, when we're doing any building, basically soil testing was basically a way of covering our backside from being sued, because we don't want a building to settle. We can, we can design a beautiful building, but if it settles, boy, we kind of slipped on something. We should have had it engineered and basically put on, we'll call it a solid footing or solid ground right from the get-go. So yeah, it's an important part. But unfortunately, not always are people. And a good example are many builders, even in my area. Very, very rare is soil testing done unless somebody really wants to push it and make sure that they're going to get a better product. But back to the illustrated user's guide. So building code to the left, illustrated guide to the right. So again, the information when it talks about the capacity in weaker soil and rock, it gives us some information about what this is all about over here. But it also gives us a little bit of a diagram indicating designing a foundation to lower the bearing capacity. So for example, why do we have wider footings? Well, we have wider footings because we want to spread out the load over a greater area. The smaller the footing, the more intense it's going to be on a particular smaller, we'll call it part of that particular underlayment or the ground beneath it. So we see here the footing width, the footing itself. There are some factors here. So this should be 2 times W. So whatever this is, if this was a 24-inch footing, anything 48 inches or below here should be solid. If it's not, so for example, let's say there's a high water table. If there's a high water table going through here, let's say even 12 inches below the ground, this footing is probably going to have to be doubled. So rather than being 24, it's going to now have to be 48. So again, soil bearing and proper balance to keep that house, we'll say, stabilized from not settling. So this is part of where the illustration helps us understand exactly what they're trying to tell us when we try and read building code over to the left. So again, just one example. There's certainly many, many examples. It looks at floor joists, it looks at beams, it looks at, you name it. When we talk about building code, a lot of it is nicely pictorially depicted in the illustrated guide. It's not code, it's interpretation of code is really what it is. So any questions or comments? And certainly, again, as a reminder, we try and put a lot of our information in our webinars, but also off of our, we'll call it our education venue called FN Learning Hub. So again, I thank you. And I certainly welcome any questions, if there's any questions that might be.
You guys have any questions? No, I think we're pretty good.
Okay, well, I will see you tomorrow. We're going to talk about drawings and blueprints and understanding drawings. I did a little bit on it because, as I mentioned, when we look at building code and the drawings kind of sync hand in hand. They kind of go together. So when we take a look at it, they kind of fit together like a nice fit in a glove. Okay.
Perfect.
Well, thank you very much. And certainly if you have any questions, C. Lawrenson at MNSI, if you want to drop me an email.